Welcome back, everyone. This is Mr. Bowman. We are going to continue talking about relationships between two quantitative variables. And today we're going to do activity 3.1b, which is going to focus on interpreting correlation, understanding the basic properties of correlation, including how correlation is influenced by outliers, and distinguishing correlation from causation. In addition to that, we are going to take a look at how to make a scatter plot on the calculator and finding the value of the correlation coefficient on the calculator, and looking at the effects of linear transformations on data and how that affects the value of the correlation coefficient. All right, everyone, let's get started with activity 3.1b. The first thing I would like to do is show you how to use your calculator to enter data, make a scatter plot, and find the value of R, the linear correlation coefficient. So the first thing you have to do is you have to make sure that you put the data into your calculator. So hit the Stat button, select Edit, and enter the data for the explanatory values in list 1 and the response values in list 2. So what I'd like you to do right now is I would like you to pause the video and scroll down to the data about the cars and the miles per gallon, remembering not to enter the data for the Audi TT. Enter the weight in the first list and the city miles per gallon in the second list, and then unpause the video to see what we do next. Alright, as you can see here, I have the weights of the cars in list 1 and their corresponding miles per gallon in list 2. One of the bigger issues with using the calculator is making sure you enter the data correctly. So a couple things I want to show you. First of all, if you put your cursor on your last entry, for this set of data, there were 16 entries, but remember, we could not put the information in for the Audi TT. So list 1 entry 15 tells us that our last entry is the 15th entry, and so we have the correct number of entries. It's a simple check. It's one that's easy to do, and sometimes it'll cause you or help you to not have problems with plotting the data. Another common mistake is students don't have the same number of x values as y values. So if you're going to make a scatter plot, it's going to plot points, and to plot points you need corresponding x and y values. So make sure those match up. If they don't, when you go to plot the data, you will get something called a dim mismatch. Sometimes that will also happen if you're using the wrong lists. So the next thing we want to do is hit second and the y equal key, and we can make up to 3 scatter plots or 3 statistical plots at a time. We don't want to do that. Let's turn them all off if they're not turned off already. And you can do that by hitting number 4 and then enter, and that turns them all off. And then we can go back and hit second and the y equal key again, and we're going to select plot number 1. We have to turn it on. We have to select the scatter plot, which happens to be the first one. We have to tell it what the explanatory value, where the explanatory values are, in this case list 1. If you had those switched, you could put whatever list you want in there. Our response values in list 2. I recommend using the square, the cross, or the box, not the little dot over here, to mark your scatter plots, because that little dot is almost impossible to see. It is impossible to see if it lands on the x or the y axis. And then you can pick a color that you want. The next thing you want to do is set up an appropriate window. We could spend a whole lot of time doing this. I don't recommend it. I would suggest hitting Zoom Stat or Zoom 9 to get a nice scatter plot for us. Now, the downside of the scatter plot on the calculator is it doesn't have any scale on the x and the y axis. So what you can do in lieu of that is hit the trace button and bounce around from point to point. After taking a look at the scatter plot, the next thing we would like to do is we would like to be able to calculate the strength and the direction of this linear association between the weight of the car and the city miles per gallon. To do that, we're going to have to do something called linear regression. And to do that, what we do is after we've made the scatter plot, we hit the Stat button, we go over to Calc, and we select either item 4 or item 8. They both work. The only difference between those two is the variables they use for the slope and the y-intercept. So let's select item number 4. And we have to tell the calculator what our explanatory list or X list is, our response list, our Y list, frequency list. That's if we have a third list to tell us how many times to count each of those points, which is seldom the case. The storing the regression equation is really, really handy. And what it does is it puts the regression equation, which we're going to talk about later, into y1, y2 in your calculator, so you can graph that at the same time you have the scatter plot. There's two ways you can just tell the calculator where to put that. One of them is to hit the alpha and the trace key and select y1 or y2. So I typically select y1. The other way that you can do that is to hit the variables button, go over to y variables and function and y1, and then we're going to calculate. So there's a lot of information here that we haven't talked about yet, the slope, the y-intercept, but what we don't see is we don't see the correlation coefficient. So to do that, you have to do the following. You have to turn something on called diagnostic, and this will get turned off anytime your calculator gets reset. To turn that on, we have to go to the catalog. So hit second and the 0 button, and you can see these are alphabetic, and you can see in the upper right hand corner the alpha key is on. So if you hit the button with the green D above it, it brings you down to the list where the D's start, and we want to select diagnostic on, hit enter to select it, and hit enter again to turn it on. Now when we go back and we calculate the linear correlation coefficient, just like we did before, we're not going to bother storing the regression equation this time, hit enter, and you will see that we have an R value of about negative 0.82. That R value at the bottom is called the linear correlation coefficient. We're going to talk later on about R squared. So remember that value of about negative 0.82 for the correlation, where the weight is the explanatory variable and the city miles per gallon is the response variable. What we'd like to do now is we'd like to redo this, recalculate R, but what we're going to do is we're going to switch the roles of the explanatory and response variables. So we go back to linear regression, and I'd like you to pause for a minute and make a prediction about what you think is going to happen with the value of R. So we are going to switch list 1 and list 2. So second and the number 2 puts L2 as the explanatory, so city miles per gallon is now the explanatory. Second and the number 1 puts weight as the response variable, and we're going to go ahead and calculate and think about what you think is going to happen here. And what you see happen is that R stayed the same. And that actually makes sense. There is a negative association between those two variables. So in other words, in the first case, as weight went up, city miles per gallon dropped. If we reversed that scatter plot, switched the explanatory and the response, you're still going to see the same relationship. As city miles per gallon goes up, weight is going to go down. So an important point about the linear correlation coefficient is that switching the explanatory and response variables has no effect on the value of that linear correlation coefficient. The next thing we'd like to do is we'd like to take a look at the range of values that R can take on. So you should recognize these 9 scatter plots from the previous activity. Well, down here is a list of the R values associated with each of those. So what I'd like you to do is pause the video, and you can go back and you can copy these from the activity, the previous activity, label the scatter plot letter A, B, C, D, E, F, G, H, I, etc. from most strongly negative to most strongly positive, the correct way, and then put in their correlation coefficients and see if you can make predictions about the range of values that R can take on. So what you see here is from our most strongly negative scatter plot or association, D, to our most strongly positive, B, the R values range from about negative 0.9 to almost positive 1. Well, it turns out that R can actually range between negative 1, which is a perfectly negative linear association where the points will all lie on the same line with a negative slope, to a perfectly positive linear association where the points would all lie on the same line with a positive slope, and in the middle where there's virtually no association whatsoever, R is very close to 0. At this point, during a normal class period, what we would do is we would pause and I would do a demonstration on Fathom for you to show you the effects on the value of R when we do linear transformations to either the explanatory or the response variable or both. And remember, linear transformations are taking all the values and adding a value, subtracting a value, multiplying them all by the same value, or dividing them all by the same value. So I'd like to use our example with our car weights and our city miles per gallon as an example. We found that the value of R was negative 0.82 approximately. And that's when we were weighing the cars in units of pounds and we were measuring the miles per gallon in miles per gallon. Well, there's no reason we have to do that. We could measure the weights in kilograms or grams or whatever units we want, and instead of miles per gallon, maybe we could do kilometers per liter or kilometers per gallon. And I guess the thing you have to ask yourself is, if we are changing the units that we use to measure these explanatory and response variables, is that going to change the strength and the direction of the association between the two? Maybe an easier way to think about this is something a little bit more tangible. There is a strong positive linear association between your height and your arm span in inches. Think about changing the units of measure from inches to centimeters, or changing one of the units to centimeters and leaving the other one as inches, or changing one of them to inches, keeping one of them as inches and changing the other one to feet. Is that going to change the strength and the direction of that association? And hopefully you're saying to yourself, no. Yet, when we change those units, we're going to have to do a linear transformation. If we're going to change from inches to feet, we're going to divide by 12. If we're going to change from inches to centimeters, we're going to multiply by 2.54, and so on. So linear transformations have zero impact on the strength and the direction of the associations between two quantitative variables, and therefore they have zero impact on the value of the correlation. All right, in this next example, we want to take a look at how you can be misled by the value of R. And the lesson here is always start out with a plot of your data. So what you're going to do here is you're going to put the month number, so number 1 for January, 2 for February, 3 for March, and so on, in list 1, and you're going to put the annual average monthly temperatures for Raleigh North Carolina in list 2. I want you to make a scatter plot, then I want you to pause and answer the questions below. So let's take a look at these questions in a little more detail. A, does there appear to be a relationship between temperature and month in Raleigh? There is clearly a relationship between those two. The graph looks like this, ignoring that line through it. So the scatter plot is clearly sinusoidal in nature. Determine the value of the correlation for these variables. Well, R turns out to be about 0.26 if I remember correctly. Let's verify that. Yep, R is about 0.26, which would indicate a very weak positive linear association. Is it accurate when you look at the scatter plot? And the answer to that question is no. It is not accurate. There is a strong association between these two variables. It's very distinct. The problem is it's not linear. So it's a common mistake for people to use the linear correlation coefficient to measure nonlinear associations between two variables. So the conclusion that you should make is make a scatter plot first. You may see strong associations, but get values of R that indicate weak linear associations. Only use R for measuring the strength and the direction of linear associations. In this example, I'd like you to do the same thing we did in the previous example, except we're going to see how R could be misleading in another way. So for your explanatory variable, use bounce number. For your response variable, use rebound height. And go ahead and put that data in your calculator, calculate the correlation coefficient, and answer these questions. All right, so when you calculated the correlation coefficient relating the bounce number to the rebound height, you got a value of about negative 0.94. Without looking at the scatter plot, most people would incorrectly interpret that to being a strong negative linear association between those two values. However, when you look at the scatter plot, you can see that it is a clearly strong negative association, but not a linear association. So, is a linear model a best fit for this data? Clearly not, and that is maybe considered inconsistent with your calculation of R in part A, but the point here is that you should always look at a plot of your data. Don't let the value of R mislead you into thinking that it's a strong association or a weak association like in the last example. Always look at a plot of your data, and remember, R is used to measure strength and direction of linear associations. All right, for the last example that we're going to do for this activity, we're going to take a look at the effect of outliers on the value of R. So you can see a scatter plot of the price of the property in the board game Monopoly versus the rent cost for that property. So the first thing you should do is estimate the value of R. And if you were paying real close attention up here at the top, the value of R is about 0.99, a very strong positive linear association. And we can see that linearity from the scatter plot. What we're going to do is we're going to fool around with the boardwalk property highlighted here in red and see what effect outliers have on the value of R. So you remember, outliers are values that lie far away from the other values in comparison. And for scatter plots, that could be in a horizontal or a vertical direction. So the first thing I want to do is I want to take this boardwalk property and I want to move it way out here to the right. And you can see that it had a significant impact on the value of R. It actually lowered the strength of that linear association, which makes sense because it does not fit the linear pattern anymore. However, if I were to move that point up so that it did fit that linear pattern, we'd be right back up there at an R value near +1. So that's an outlier in the, we'll go back to the original case here. This is an outlier in the horizontal direction only that doesn't fit the pattern. It has an impact, a significant impact on the value of R. This is an outlier in both the horizontal and vertical direction, but it fits the pattern of the rest of the data in terms of the linear association. Now what we're going to do is we're going to move that point about back to where it started, but then we're going to move it over this way, and it doesn't really fit the pattern, but it doesn't have too much of an impact on R. If we start moving it further to the left, it has a huge impact on the value of R. And I would argue that in some ways this point really isn't an outlier in either direction, in either the x direction or the y direction. So when we talk about scatter plots, we talk about outliers and influential points. And outliers really mean points that lie far above or below in the vertical direction, or far to the left or far to the right in the horizontal direction compared to all the other points. And so what you really need to do when you're addressing outliers is look at that aspect of the scatter plot. Influential points, on the other hand, are points that have a big influence on the value of R. So this point, Boardwalk, moved way out here, is an outlier in the horizontal direction, but it's also an influential point because it has a significant impact on the value of R. If we move it over here, it's not an outlier in either direction, but it's an influential point. So influential points tend to be outliers in the horizontal direction that don't fit the pattern. If we put the point back over here, it's not an outlier in either direction, and it clearly doesn't fit the pattern. It has some influence on the value of R, and more as we move it away, but not quite as much. So we've covered a lot in this activity, and what I would like you to do is take some time at the end of this activity and read these bulleted items on the summary of the correlation coefficient R. They are all very, very important.